Hey, hello there. Going to be going over solutions to the mid-unit review. So if you have any questions about how to do these problems, go ahead and watch the video. In the comments, there's a timeline so you can skip ahead to specific problems if you need to. All right, we're going to get started here on problem 1. So we are simplifying each fraction. What we're trying to do is find a number that we can divide both the top, the numerator of the fraction, and the bottom, the denominator, by. So in part A here, I have a 4 and a 6. I think to myself, I can divide both of those numbers by 2. So I'm going to divide by 2 in the top and bottom. And the top, that's going to leave me 4 divided by 2 is 2. 6 divided by 2 is 3. So 2 over 3. Part B, I've got a 12 and an 8. Those are both divisible by 4. So I'll divide by 4 top and bottom. 12 divided by 4 is 3. 8 divided by 4 is 2. This was originally a negative fraction, so we'll keep it negative. Negative 3 over 2 for our answer. Part C, we've got a 9 and a 12. Those are both divisible by 3. 9 divided by 3 is 3. 12 divided by 3 is 4. So positive 3 over 4 is the reduced fraction. Part D, 6 and 18. So there's actually more than one thing that both of these are divisible by. We want to go for the biggest one. They're both divisible by 2. They're actually divisible by 3, but they're both divisible by 6. And 6 is the biggest thing that we can divide into both. So we'll divide by 6. 6 divided by 6 is 1. 18 divided by 6 is 3. This was originally a negative fraction, so we'll keep it negative. Now, let me show you something here really quick. What if I was working on this and I didn't recognize that they were both divisible by 6? Let's say I looked at it and I thought, oh, they're both divisible by 3. So I can go ahead and do that. I'm going to divide by 3 on the top and bottom. 6 divided by 3 is 2. 18 divided by 3 is 6, and it's a negative fraction. But when I look at that answer, I recognize, hey, wait a second, those are also both divisible by something. They're both divisible by 2. So let's divide top and bottom by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. And it was a negative fraction, so I end up with negative 1/3 for my final answer. And that's exactly what we got when we did it the other way. So you can divide by anything you want. You just have to check and make sure that that was the biggest, that you can't divide by something else. So we may see that pop up again. All right, part E here, 15 and 10. We can divide both of these by 5. 15 divided by 5 is 3. 10 divided by 5 is 2. So 3 over 2. Next up, we've got 3 over 12. 3 and 12 are both divisible by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. So we get 1/4. G. Now, actually, I know that 24 divides by 6. So I can do this a little bit easier. I'm just going to go ahead and put that negative in here. And what is 24 divided by 6? 24 divided by 6 is 4. So negative 4 is my answer. Now, there's other ways to do this. If I had decided, oh, I can divide them both by 6, that is the biggest thing that goes into both of them, then I would have gotten 24 divided by 6 is 4. 6 divided by 6 is 1. Put that negative out in front. We get negative 4 over 1, which is the same as negative 4. So either way we do that, we're getting the same answer of negative 4. Moving along, this next one, 9 and 4. The biggest number that divides into both of those is 1. So this one actually does not reduce any further. The instructions did say if possible. So 9 over 4 is 9 over 4. Can't go any further. All right, we've got 14 over 8. Those are both divisible by 2. 14 divided by 2 is 7. 8 divided by 2 is 4. Don't forget your negative sign, negative 7 over 4. Next up, we've got 10 and 20, which are both divisible by 10. 10 divided by 10 is 1, 20 divided by 10 is 2, so 1/2. 8 over 20. 8 and 20 are both divisible by 4. 8 divided by 4 is 2. 20 divided by 4 is 5. This was a negative fraction, so we'll keep it negative 2 over 5. Finally, 14 over 21. 14 and 21 are both divisible by 7. 14 divided by 7 is 2. 21 divided by 7 is 3, so 2/3 for our final answer. Okay, it is time for us to move on to number 2. In each of these, we are finding a slope and a y-intercept and then writing an equation. Let me adjust my camera so we can get everything on the screen at once here. All right, so to find a slope, we're going to need a couple of points on the line. So I am going to go ahead and pick off these 2 points here, and I'm going to draw a slope triangle. And I'll label my rise and run. My rise is 2, and my run is 1. My slope is rise over run, but I need to recognize that this is a negative slope. It is going downhill from left to right. So my slope is going to be negative 2 over 1, which is just negative 2. My y-intercept is right here. It crosses the y-axis at 3. 1, 2, 3. If I know my y-intercept and my slope, I can write my equation. The equation here would be y equals the slope comes first attached to the x, so negative 2x, and then my y-intercept was positive 3. Y equals negative 2x plus 3. Next one, we'll do the y-intercept first this time. The y-intercept is at negative 2. Then I want to find a couple points to do my slope. It doesn't matter which 2 points you pick, but pick some points that go through some good lattice points, some points that go through some grid crossings. I'll pick those 2 and draw my slope triangle and label. I have 1 unit across the bottom and 1, 2, 3 spaces up the side. Slope is rise over run, so that's going to be 3 over 1. And we'll just double check, is this a positive or negative slope? It is going uphill from left to right. So it's positive. So positive 3 over 1, that's the same as 3. I have my slope and my y-intercept. It's time to write the equation. Y equals, the slope was 3x, y-intercept was negative 2, so minus 2. Y equals 3x minus 2. Okay. Y-intercept first. The y-intercept is 1. And I'm going to need a couple of points. Let's see. Here's a good one here. And now we can use the y-intercept. Let me draw my slope triangle. I'll recognize that this is a positive slope. It's moving uphill from left to right. Across the bottom, I got 2. Up the side, I got 3. For a slope, we want to do rise over run. That would be 3 over 2. That does not reduce, so we'll leave it just like that. So my equation is y equals slope comes first, and then x, and then my y-intercept. Okay, last row. Y-intercept is at 3. And for my slope, I'll need to find a couple of points. I'm going to use this one here and this one here. Remember, you can use any 2 points that are on your line. So if you use different ones than me, that's fine. I'm also going to notice that this slope is going downhill from left to right, so my slope will be negative. Got 2 along the side, and then 1, 2, 3, 4, 5, 6 across the bottom. Rise over 1 would be 2 over 6. Now that does reduce because 2 and 6 are both divisible by 2. So let's divide them both by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. So negative 1/3 for my slope. That makes my equation y equals negative 1/3 x. That's a positive 3 for my y-intercept. y equals negative 1/3 x plus 3. Couple more here. As usual, we're starting with our y-intercept. This one is at 2. We'll find a couple good points for our slope. This one's a little tricky. I'm going to use this one here, and the next good point that I see is right at the arrowhead there. So that's our slope triangle. 1, 2, 3, 4 spaces across the bottom, 3 spaces up the side, and I'm noticing that this is a positive slope. It's going uphill from left to right. My rise over run is 3/4, and that does not simplify, so my final equation is y equals 3/4 x plus 2. Last one in this section, y-intercept is at -3. To find my slope, first of all, notice it's going downhill from left to right, so it's a negative slope. Picking a couple points, I'm going to pick this one and this one. But remember, you can pick any 2 points on the line. And I've got a rise of 2 and a run of 2. That does simplify. 2 divided by 2 is the same as 1, so my slope is -1. That makes my equation y equals -1x minus 3. A lot of people, when they write this, would actually leave that 1 out, but the negative does need to stay. So if you wrote that as y equals -x minus 3, that also works. We are on to page 3. This time around, we are graphing lines. I'm going to get my ruler out and ready to go. When we graph lines, we need 2 pieces of information. We need a slope and a y-intercept. All right, so my first equation here has a slope of 1/2, and it's positive. I'm going to go ahead and sketch myself a positive slope and slope triangle. My rise over run is 1/2, so up 1/2. And we are going to start at +1 on the y-axis. So there's my first point, and then from there I need to go up 1/2. So up 1/2, up 1/2. And once I get to the edge, we'll go ahead and back it up and go down in the opposite direction. Grab our ruler, draw ourselves a nice line. Make sure it goes from edge to edge, and let's not forget to put those arrowheads on there. All right, my next equation has a negative slope. So I'm going to go downhill from left to right. Just a second. And we're back. All right. Slope -3/4. So I got my negative slope. My rise over run is 3 and 4. And then I need a starting point. My y-intercept is -4, which is right here on my y-axis. So from that point, I need to do my slope down 3 and over 4. So down 3 and over 4, I'm actually running off my graph here. It would be about down 3 and over 4 would be about there. But I could go up 1, 2, 3 over 1, 2, 3, 4, and that gets me to there. I can try and go again, but that's going to run me off my graph again. So that's the only 2 points I'm going to get, but 2 points is enough to make a line. Don't forget your arrowheads. And then to finish this up, they did ask us for the point of intersection. We're just going to write down the coordinates of that point. Here's where the lines cross. The x coordinate is -4, so -4 comma the y coordinate is -1. -4 comma -1. Don't forget your parentheses around those, folks. Move on to our second graph here. All right, this one has a positive slope, so I'm going to draw myself my little slope triangle in the positive direction. Rise over run is 2/3. And we are going to start this one at a y-intercept of -1. So -1 on the y-axis is my first point. And from there, I need to count up 2 and over 3. So starting here, up 1, 2, over 1, 2, 3, up 2 over 3. And then we'll go back and back it up the opposite direction. Draw our line, get some arrowheads on that one. Right. We got a negative slope for our second line, so my slope triangle is going to be going downhill. And my rise over run is 2/3. This time I will be starting at positive 3 on the y-axis. So my first point here is positive 3, and I need to follow my slope triangle down 2/3. So down 1, 2, over 1, 2, 3 gets me to here, down 2/3. And then we'll back it up 2/3, and that's as far as we're going to go until we run off of the graph. So here's my second line. Don't forget your arrowheads. And we see a nice intersection point here. That point has an x-coordinate at 3. So my x-coordinate is 3, my y-coordinate is 1, so 3, 1 for the point of intersection. All right, next up. All right, this slope is a little bit tricky because there's no number in front of the x. It is a negative slope. So I'll sketch my negative slope triangle. And when we see something without a number in front of a variable, we know we can always put a 1 in there. We kind of like slopes to be a fraction. So instead of a 1, I'm going to make it a 1/1. So when I do my slope triangle, I'm going to be counting down 1/1. Let's find a starting point for ourselves here. My y-intercept is at -1. So we'll draw our first point here at -1 on the y-axis. And then we'll use our slope triangle. We'll go down 1/1, down 1/1, down 1/1. Ooh, we're going to have a bunch of dots on this line. We'll back it up and go the opposite direction, right off the edge of the graph, and then we'll draw our line. Okay, second equation. Ooh, this is an interesting one also. There is no x in this equation. It says y equals 1. Y equals 1. Another way we could write this would be y equals 0x plus 1. That 0 means that the line is going to be flat, and the 1 is going to be our y-intercept. So it's going to go through this line, and it's going to be a flat line. It's going to look something just like this. So a horizontal line crossing through the y-axis at 1. Another way to think about this is a rule for every point on this line. If you think about this line, every single point on this line has the same y-coordinate. They all share the y-coordinate of 1. All right, with both lines drawn, we can find our point of intersection. And let's write this down, get our parentheses and our comma so we don't forget those. X comes first, my x-coordinate is -2. Y next, my y-coordinate is +1, -2, 1 for my point of intersection. All right, one more, folks. You're doing great. All right, we've got a slope. It's -2. I'm going to write that as -2/1. Since it's a negative slope, I'm going to draw a line going downhill, turn that into a slope triangle. 2/1, rise over run. It's going to give me 2/1. My y-intercept or starting point is at -4. So on my y-axis, I'll draw my first point at -4. And from there, I'll go ahead and do my slope -2/1. So starting here, down 2/1. And then we're off the graph, so we'll back it up the opposite direction and draw that line. All right, one more line to draw here. Okay, this one has another negative slope. It has a negative slope, so I'll draw my negative slope triangle. And this time around, rise over run is 1/4, so 1/4. We will start this at the y-intercept, which is +3, so I'll go to my y-axis and find +3. And from here, we need to do our slope, which is down 1/4. So down 1/1, 2, 3, 4 spaces. Down 1/4 is going to get me off the graph, but I can back it up and go up 1/4 the opposite direction. That gives me a few points to draw a line. Get my arrowheads on there. And last thing we'll do is find our point of intersection, which is right here. Coordinates of that point, the x coordinate is -4, and the y coordinate is +4. All right, we are moving right along to number 4. Okay, here we are filling in a table. We're just going to look at the equation, find the start value and the rate of change, and fill in our table. So let's go ahead and get started on this. Starting value is always going to be the number that is by itself without the x. In this case, it is a 7. And the starting value is always going to be the y value when x is 0, so that 7 is going to go right there. The rate of change is our slope, or the number in front of the x. So my rate of change here is going to be 3. And the rate of change tells us how we are going to change as we progress through our y values. So I know that because it's a +3, we're going to be adding 3 each time. So we're starting at 7, plus 3 is 10, plus another 3 is 13, plus another 3 is 16, plus another 3 is 19. We're moving on to part B. In part B, our starting value is 20. Starting value always goes with the x value of 0. It's like our y-intercept. Our rate of change in this case is -2. So we are going to be subtracting 2 as we move forward through our y values this time. So we start at 20, -2 is 18, minus another 2 is 16, minus another 2 is 14, minus another 2 is 12. The last half of this problem is on your next page. So let's flip over. Part C. Starting value is the number not attached to the x, so that's -6. And that will always be the y value when x is 0, so we can fill that into our table. Our rate of change is the number attached to the x, the coefficient on the x. In this case, there's an invisible 1 there, so our rate of change is -1. So this time we are going to be subtracting 1 in our y values. So -6 minus 1 is -7, minus 1 is -8, minus -1 is -9, minus 1 is -10. Last one for number 4. We've got some decimals here, but we can deal with it. Starting value is +12.5. As always, that will be the y value when x is 0. My rate of change is 2.5. That tells us we are going to be adding 2.5 as we progress. All right, so you may want a calculator for this. 12.5 plus 2.5 is 15, plus another 2.5 is 17.5, plus another 2.5 is 20, plus another 2.5 is 22.5. And we're done with number 4. All right, number 5 is basically the opposite. We need to find a starting value and a rate of change. Then we're going to write the equation. Basically the opposite of what we've just done. There are a couple tricky problems in here. D and F in particular are going to be a little bit tricky. But let's start with some of the more basic ones. All right. So what do we need to know? We need to know the starting value is always the y value when x is 0. So look in your table, find that place where x is 0. In this case, 5 is our starting value. The rate of change is how we are changing in the y's. All right, so in this case, it looks like from 5 to 8, we're going +3. From 8 to 11, we're doing +3. So my pattern is that my rate of change is +3. I just need to put those two values together into my equation. By equals rate of change comes first, attached to the x, plus starting value at the end. So y equals 3x plus 5. All right, part B. Starting value, again, we want to look for when x is 0. What is the y value? In this case, it is 20. Rate of change is going to tell us how to move from one y value to the next. From 32 to 26, what am I doing? I'm definitely subtracting something. How much though? 32 minus 6 gets us 26. 26 minus 6 gets us 20. So that's my pattern. My rate of change is -6. Therefore, my equation is going to be y equals -6x plus 20. Part C, looking for a starting value. I see an x value of 0. That means my starting value is -22. And then how are my y values changing this time? From -2 to +8. I must be adding. Actually, this is a little easier to see. From 8 to 18, that's +10. -2 to, yes, that's also +10. So my rate of change is +10. That makes my equation y equals 10x minus 22, since my starting value is negative. All right, D gets a little bit tricky. And the tricky thing about D is there is no starting value. I don't see an x value of 0. So what we're going to need to do is kind of work backwards. Let's figure out what our rate of change is first. What gets me from 10 to 14 and from 14 to 18? I think that's +4. So my rate of change is +4. I'm really close here to 0, so I'm going to kind of get rid of this x and this y, and let's work it backwards. So 3, 2, this would be 1. I'm going to add one more column in here. This would be 0, and that's going to be my starting value. So we just kind of need to work backwards. To go forward, we're doing +4. What would I need to add 4 to get 10? This must be a 6. 6 plus 4 is 10. And then what's my starting value? What do I add 4 to get 6? 2 plus 4 is 6. So my starting value actually ends up being 2 for this one. We had to do a little bit of work to get that. But once we have our starting value and our rate of change, the equation is simple. Just get the numbers in the right place. Rate of change comes before the x, starting value at the end. All right, part E looks a little bit weird because of the decimals, but it's actually pretty straightforward. We've got a starting value, easy to spot here at 13.1. And we just need to ask ourselves, what are we doing as we go forward in this table? 7.1 plus something, plus how much gets us 9.1? That's just +2. 9.1 plus 2 gets us 11.1. So my change is just +2. And then my equation would be y equals rate of change comes before the x, starting value goes at the end. Don't forget your plus here. And we're good to go. All right, now F is tricky in the rate of change. Let's do the starting value first because it's just like everything else. We find an x value of 0, that gives us our starting value. The rate of change is different for this problem, though, than it has been for any of the other ones. So I want to go back and point out to you that for each of these other problems, the x values were always going up by 1. 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. This one is a little bit different. These x values are going up by 2. So when we do our rate of change, we actually need to think about what is the change in x and what is the change in y. So I'm just going to pick a couple of points. I'm going to focus on these two right here. We need to do a change in x and a change in y. The change in x here is +2. The change in y here, 13 to 18, is +5. So the rate of change for this one is going to be, remember, it's change in y over change in x, 5/2. So this one was trickier because the x values were not going up by 1s. They were going up by something other than 1s. In that case, we have to figure out what is the change in x as well as what's the change in y. And turn those into a fraction. Remember, it's always change in y over change in x. This is a pretty advanced problem. If you're not quite here yet in chapter 2, that's okay. We're going to be practicing this a bunch in chapter 3 also. All right, let's find our equation. Y equals rate of change comes before the x. Starting value is 8. And we are done with number 5. All right, we're moving on to number 6 now. Okay, so what do we need to know for this? Slope. Slope is equal to change in y over change in x. So the way I like to do this, there are many, many different ways to do it. The way that I prefer is I like to stack my points on top of each other. So let me rewrite, these are the same 2 points that we just had. And then I will use these 2 points to figure out what is my change in y. These are my y values. And then what is my change in x? These are my x values. And then I'll turn that into my slope. So I need to think, what do I do to this y value to get to this one? What do I do to a -3 to get to a 2? I must be adding something. How much am I adding to -3 to get to 2? That's a +5. All right, what about from a 5 to a -5? We're definitely subtracting. How much do I need to subtract to get to -5? 5 minus 10 gets me to -5. So my slope, m, is change in y over change in x. So it would be 5 over -10. We can simplify that fraction because both of those are divisible by 5. So 5 divided by 5 is 1, 10 divided by 5 is 2. And let's think about the sign on this. It's a positive divided by a negative. Whenever the signs are different, you're going to get a negative slope. So -1/2 is our slope between those 2 points. Let's follow that same procedure here for part B. So let me stack my points on top of each other. By the way, it does not matter which order you stack them in. And I'm just going to go ahead and label my x's and y's. All right, so from -2 to -18, I'm getting more negative, so I'm subtracting 2 to 18 is 16. So my change in y is -16. And my change in x, I'm going from 4 to 16. That would be adding 12. Slope is change in y over change in x, so that would be -16 over +12. And then I need to simplify. What can I divide into both of those? 6 goes into 12, but not into 16. 8 goes into 16, but not into 12. 4 goes into both of them. So 16 divided by 4 is 4. 12 divided by 4 is 3. And my signs are different, so it's going to be a negative slope overall. Okay, let me show you a little trick. If you're having any trouble figuring out these changes, there's an easy way to do it. using a calculator. So if you are struggling a little bit, especially with the signs, let me show you how you can do this with the calculator. What I'm going to do is I'm going to take my y values. I'm going to do the second one minus the first. So I'm going to do negative 18 minus negative 2. Negative 18 minus negative 2. And that's going to give me the negative 16 that I have right here. If I wasn't sure what my change in x was, I'd do the second one minus the first. So 16 minus 4. That will give me that 12. I encourage you to try and do the change in your head if you can. But if you need to rely on a calculator, just do the second one minus the first. Okay, let's move on here. I'm going to stack these 2 points, negative 12 comma 15 and 12 comma 15. Let's do our change in y and our change in x. All right, my change in y, 15 to 15, that's 0. We didn't change at all. My change in x, now it's the same number, but one's negative and one's positive. I'm going from a negative to a positive. I believe that's plus 24. But again, I can use my calculator to check. I'm just going to do the second one minus the first. So 12 minus negative 12. Oh, it is 24. That's great. Okay, so my slope then is going to be change in y over change in x. That's 0 over 24. 0 divided by anything is 0. So we have a 0 slope for that one. This last one's got some pretty big numbers, so I think I'll probably be relying on my calculator just to check. Make sure I've got the correct values. So 4861. 70 comma negative 19. So let's find our change in y and our change in x. All right, so from 61 to negative 19, I'm going to rely on my calculator for this one. Second one minus first. So negative 19 minus 61, negative 80. So my change in y is negative 80. And then for my change in x, I'm going from 48 to 70. I think that's going to be positive. We can figure out how much by doing second minus first. Now, let me try and do that in my head. I think it's going to be 22. But let me check. Second minus the first. Yes, it was plus 22. So our slope is going to be change in y over change in x. That's negative 80 over positive 22. And those are both divisible by 2. So let's try that and then see if we can go further. So 80 divided by 2 is 40. 22 divided by 2 is 11. Positive divided by a negative would be a negative slope. And 40 and 11, those do not have anything that goes into both. So that's going to be our slope, negative 40 over 11. That's it for number 6. Moving on to our last page. This is all going to be review from chapter 1. So we're going to start with number 7 here. We're going to solve these equations and show our steps, of course. All right, so let's get started here. First thing we want to do is combine like terms. I cannot combine these because they don't both have x's in them. Same thing over here. These two terms are like terms, but we cannot combine across an equal sign. This equal sign is kind of like a wall between those two things. So no like terms to combine. The next thing I look for is, do I have x's on both sides? And I do. I can't solve an equation with x's on both sides. So I'm going to get rid of the 5x or the 2x. You make your choice. It really doesn't matter. I'm going to choose to get rid of my 2x. I'm going to go minus 2x to cancel that out. But of course, I have to do the same thing on both sides of my equation. So I'll do minus 2x over there also. These go away. Over here, I have 5x minus 2x, which is 3x. I'll bring down my plus 13, bring down my equal sign, and bring down this negative 2. All right, now we only have x's on one side, so we can focus on solving and getting this x by itself. First thing I'm going to do is get rid of this plus 13. Always do plus and minus first. So let's do minus 13. That's the opposite on both sides of the equation. These are going to cancel. The 3x will remain. We've got an equal sign, and negative 2 minus 13 is negative 15. We just need to get rid of that 3. That 3 is multiplying by the x, so we will divide by 3 on both sides. Those will cancel. Now x is by itself. Equal sign comes down. Negative 15 divided by 3 is negative 5 for our final answer. All right, part B, let's see if we can combine some like terms. We do have some this time. Pardon me, let me draw my equal sign barrier. I've got a 7x and a negative 3x that I can combine together. So 7x minus 3x is going to give me 4x. We'll bring down this plus 12. That doesn't combine because it doesn't have an x. And our equal sign. And then over here, I have a 1 and a negative 11 that don't have an x. We can combine those together. 1 minus 11 is negative 10. The 2x can't combine, though, because it's got an x, and the 10 does not. So we've combined like terms. The next thing we look for is a variable on both sides, and we do. We have x's here and here. We need to get rid of one of them. I'm going to choose to get rid of this 2x over here. Let's go minus 2x on both sides. And then I'll only have an x left on the left-hand side. 4x minus 2x is 2x. We'll bring down our plus 12, bring down the equals, bring down our minus 10. Now we only have a single x. We'll focus on getting it by itself. Always get rid of addition and subtraction first. This is a plus 12, so let's go minus 12 on both sides. Those will cancel. My 2x comes down, my equals comes down. Negative 10 minus 12 is negative 22. One final step, that 2 is multiplying by the x. Let's divide by 2 to cancel it out. 2's cancel out, now x is by itself. Negative 22 divided by 2 is negative 11. All right, we're moving on to number 8. So these are some expressions with a's and b's and c's, and they gave us some values to use for a and b and c in the problem. So we're going to show work for this. The first thing we're going to do is we're going to take out our variables and replace them with these numbers. I like to use parentheses when I do this. Original expression was 4b. I left my b out. Minus 3a, and I left my a out. And I'm going to replace the b that was here with the 4 with a 5, and I'm going to replace the a with a negative 2. All right, order of operations says that we take care of multiplication first. I do have multiplication right here, 4 times 5, that's 20. And I've got more multiplication here. I got a negative 3 times a negative 2, that's a positive 6, plus 6. And then we can finish this up. 20 plus 6 is 26 for our final answer. All right, let's look at part C here. So I'm going to copy over that expression, and I'm just going to leave out my b and my c. So negative b minus 5c. I've left some spaces to put in those numbers. Where the b was, I'm going to put a 5. Where the c was, I'm going to put a negative 6. All right, let's keep this going. So this negative is sitting in front of that 5. There's nothing to multiply here, so I'll just drop the parentheses. But I do have a 5 right up against a parentheses here. It's actually a negative 5. Negative 5 times negative 6 is going to give me a positive 30. I'm running out of space below, so we'll go off to the side here. Negative 5 plus 30 inside of the square root. Negative 5 plus 30 is 25. And then to do the square root of 25, I need a number that can multiply times itself to equal 25, and that number is 5. Final answer is 5. All right, let's keep it rolling. This next one's got B and A and C in it. So just like before, I'm going to start by rewriting the expression, but just leaving out all of the variables. Let's put these numbers and get them in the right spot. So the first one was a B, which is a 5. Next was an A, which is a -2. And the last one was a C, which was a -6. Simplifying this 5, there's nothing multiplying, so we can drop the parentheses. Let's leave this absolute value in here and do the multiplication first. 2 times -2 is -2. Plus a -6 is the same as -6. Plus a negative is the same as minus. All right, we do need to finish up what's inside of the absolute value first. So what is -2 minus 6? Well, that is -8. Now we can take the absolute value of that. Let's keep our 5 here. So the 5 was here from before, plus. And then what is the absolute value of -8? That's just 8. So our final answer, 5 plus 8 is 13. Last problem here in number 8. B squared minus 4AC. So let's go ahead and rewrite this. B squared minus 4AC, and we'll get our numbers in here. So B was first, that's 5. A was -2. C was -6. All right, exponents come first in PEMDAS, so let's do this 5 squared. 5 squared is 25 minus, and then I still have 4 times -2 times -6. Now I can actually multiply. I've got 3 things being multiplied together. I need to multiply them 2 at a time, and I can do them in any order I want. So I could start by doing the -4 times the -2, or I could start by doing the -2 times the -6. I actually could do the -4 times the -6 first if I wanted to. I think I'm going to go ahead and choose to do the -2 times the -6 first. So I'll leave the 25 alone. I'll leave the -4 alone, and then I'll multiply -2 times -6, which is +12. Running out of room, we're going to need to come back up here. All right, so we got subtraction and we got multiplication. Multiplication is going to come first. So let's leave that 25 alone. Got a -4 times a +12. That's going to be a -24. One last step to finish it up. 25 minus 24 is equal to 1. All right, that's the end of number 8. Finally, moving on to number 9. You guys are doing great. Let me zoom this out because we got quite a bit of work to do on this one. We need to fill out this table and graph it, and then we're going to fully describe our graph as well. So let's start by filling out our table. All right, to do this, we're going to need to be plugging these numbers in for x. So let me go ahead and get this set up first. So we've got -x² plus 4. And the first value I'm going to put in for x is -3. All right, so let's work this out. The exponent has to happen first. So the negative is going to stay. When I do a -3 times a -3, I'm going to get a +9. And then we've got this +4 still at the end. I got a -9 plus 4. That's going to give me a -5. All right, let's set it up to do the -2. So -x² plus 4. And this time I'm going to plug this -2 in. All right, so let's do this. The negative is going to stay. We've got to do the exponent here first. -2 squared. That's -2 times -2, which is +4. And we still have our +4 at the end. -4 plus 4 is 0. And we're just going to keep working through this. So I'm going to go ahead and get this set up for all of these. We're going to end up doing this 1, 2, 3, 4, 5 more times. So I'm just going to get it set up. It's always -x squared plus 4. -x squared plus 4. -x squared plus 4. -x squared plus 4. The only thing that's going to change is what we're going to plug in for x. So next up is -1. And then we will do 0. And then we will do 1. And then we'll do 2. And then we'll do 3. And then we'll be done and we can graph it. So let's work through these. So the negative is going to stay. -1 squared, that's -1 times -1, which is 1. We still have our +4. -1 plus 4 is 3. The negative is going to stay. 0 squared is 0 plus 4. So 0 plus 4 is 4. Negative stays. 1 squared, that's 1 times 1 is 1. Plus 4 is, well, -1 plus 4 is 3. The negative stays out front. We've got 2 squared. 2 times 2 is 4. And then we have our +4. -4 plus 4 is 0. And finally, the negative stays. 3 squared is 9. And we still have our +4. -9 plus 4 is -5. So that was a little tedious, but we were able to get all those points. Let's go ahead and graph them. So we've got -3 in the x and -5 in the y. Be this point here. We've got -2, 0. We've got -1, 3. We've got 0, 4. We've got 1, 3, 2, 0, and 3, -5. And we know because this is an x squared that this is going to create a parabola. So I'm going to go ahead and draw that parabola here. And we are ready to do the final step, which is to fully describe the graph. All right, so what can we pull off of this thing? I like to start with x and y intercepts. So we've got a couple of x-intercepts here and here. This is -2, 0. That's 2, 0. While we're at it, let's go ahead and do a y-intercept. We have one here that is 0, 4. Other special points would be a vertex. This graph does have a vertex. The vertex is the point where it turns around, and that's at the same place that the y-intercept was, 0, 4. Let's talk about maxes and min. The max is the highest point on the graph, which is, well, at that same point, 0, 4, a very popular point. And the min is the lowest point on the graph. Well, we know this graph's going to keep going down forever and ever on both sides, so there is no minimum. We're going to write none for that. Right? Does this graph have symmetry? Yes, indeed, it does have a line of symmetry. It's this vertical line right here. And we now know how to write the equation of that line. Vertical lines get a simple equation that just says x equals some number. Think to yourself, what is the x coordinate of every point on this line? 0. So x equals 0 is our line of symmetry. What am I missing? Oh, we didn't do the shape. This is a parabola. And we can get more specific and say that it opens down. And the only other thing I can think about would be domain and range. So my domain are the x values. How far does it go on the left? How far does it go on the right? I'd say to the left it goes, well, forever and ever to negative infinity. And on the right it goes forever and ever because of the arrow, so negative or positive infinity. Finally, our range. The range goes from bottom to top. So what's the lowest point on this graph? Well, it keeps going down forever to negative infinity. And to the top, what's the top of this graph? Well, the highest it ever gets is right here, and that y value is 4. So remember, domain gives us x values, range gives us y values. All right, thank you so much for your attention. Have a great day.